thank you for attending my presentation. The presentation title is Supervised Learning with Software AUC Laws for BirdCLEF 2025. This is a template. I'm a self-learner. I learned all my AI or machine learning knowledge online from the internet. Yeah, also, of course, I read some books, but most of my knowledge was from the internet. I learned knowledge from skill from the internet. I also work on internet. I'm a freelance programmer. Yeah, do some AI related jobs. Recently, in recent years, I practiced participated in various machine learning data science competition to win the prizes. Actually, this is my main income source. I'm a kind of prize hunter on Kaggle, German data, and top coder. I participated in some audio classification competition. The last audio classification competition I won was this on German data. This actually is a speech text matching competition, but I just treated it as audio classification on German data. I was second place. The code is open source. And the summary. I use the SED solution, inspired by the BirdCLEF 2023 second place solution. And also I use the custom software AUC laws. This is very important. This helped me improve my place from the 11th on public leaderboard to 4th on private leaderboard. I will explain it later. And the semi-supervised learning, yeah, just to use all the unlabeled data like others solution. Only 2D bench normalization. I tried a lot of data normalization method, but only 2D bench normalization from the BirdCLEF 2023 second place solution worked. The training time was about 50 hours on 4090, including the 10 hours data processing part without need of GPU. Yeah. Feature selection and engineering. I did some hyperparameter tuning and found out it seems like only these two parameters matter. Hope length, smaller hope length, and larger males. Other hyperparameters seem not so important. And human speech filtering. Human speech. This is directly from public notebook. And frequency dropout, frequency masking. Actually, this is one part of my data augmentation part, but this is the most important. Not only the high frequency masking, but the full frequency masking, and mix up both audio and mirror spectrogram. And this is the important side. The important side that's less than this will cause a drop on the leaderboard score. Training methods. SED mode training. Yeah, so since I use SED mode, the training is also SED mode training method. I found that the SED mode is more stable, way more stable than classification mode. Actually, if you train the classification mode, after about 10 epochs, you will get overfitted to the training data set. But you can try a lot of more epochs, the SED mode. It's more stable, and also this SED mode will less sensitive to random set. Custom AOC laws, software AOC laws, which is, it seems very resistant to overfitting. Supervised learning to make use of unlabeled data. 10 efficient net modes as the labeling mode. Yeah, firstly, I tried 10 efficient net modes from the small one to large one as the labeling mode, and then use the labeling mode to generate the schedule software labels. Super sampling of classes with few samples, that is real classes. This is also the common technique. 16 efficient net modes as the final solution. Only efficient net works. I don't know why. I tried ResNet. I tried a vision transformer. None of this worked. Next, this is the code of my loss. Actually, this is the so-called AOC loss is not the same as AOC metric, but it is for AOC metric. You can see this part. This part is. Can you see the mouse?
Yeah, we can see it.
Okay. So, this part is the software level part. I use the concept of the sample weight to implement the software labs, and this is the loss part. You can see instead of directly optimizing the absolute possibility, like cross entropy loss, this loss will optimize the relative possibility. Training with this loss will enlarge the difference between the positive predictions and the negative predictions. Because AOC metric relies on relative possibilities, not absolute. It relies on the kind of order of the possibilities. So important and interesting findings. A small amount of unlabeled data from the past computation with software labels, software pseudo labels, improved the mode slightly. I was trying to find some additional data. So I tried the unlabeled data from past computation. I selected a small amount of that based on the summary of the software labels. It improved the mode slightly, but because it was very time consuming and the domain, actually the data domain of past computations is different from the current domain. So I didn't add this method to my final solution. Maybe next time I will try to find a way to use the unlabeled data from the past computation. Deleting the predictions, that means they all to zero over some classes. Some real classes had little impact on leaderboard score. It seems that my mode cannot efficiently predict these classes. I don't know if it's only me or other participants also face this problem. This is the example. Example of the class 963335. This class has only one sample. So basic predictions, this is the basic predictions. This is the basic predictions, but where all the predictions of this class were set to zero. You can see the result barely changed. And also, this is a base predictions where the prediction of this class was set to 1 minus original predictions. That means the order of predictions is reversed. So the result still barely changed. So my mode is able to predict classes like this, I guess. Simple mode. Efficient net V2S contributes the most. It has the highest weight in my final solution. If you want to get a faster solution, you can just remove some large modes. Yeah, it's simple because I use all the modes I used is efficient net from small one to large one, and yeah, and you can also reduce the size of the import image import feature because efficient net takes dynamic import size, and I recommend you to retrain it after you change the import size. Solution overview. Biggest advantage is the custom soft LC loss. And 16 efficient net modes is my final ensemble. And most unlabeled data was used for semi-supervised learning. Unlike some of other solutions, I use almost all unlabeled data and generated the schedule labels for them and post that to base training data as the one data set. Actually, I just cut the 10% of the unlabeled data with a few lower summary of the soft labels as schedule labels. Okay, it's Q&A time. Thank you.